Well, welcome everybody. My name is Blaine Stum. As Anna Kuzman said, I am a program assistant here at the Justice Programs Office, and I am actually going to introduce our two presenters for today, who are going to give us sort of a rundown on the science and practitioner perspectives on synthetic drugs and drug courts having to deal with synthetic and designer drugs. Our presenters today are Dr. Leo Kadehjian, who is an independent biomedical expert based out of California in Palo Alto, and he has a ton of experience doing on-site testing and doing expert testimony on drug testing and sort of drug science, and so we're really excited to have him. He'll be explaining sort of the science behind the drugs. And then we also have Natalie Reyes, who is the program coordinator for Multnomah County's START Drug Court program in Portland, Oregon. And she'll be giving us a rundown of sort of practitioner perspective and how to deal with synthetic drugs and designer drugs as a drug court. And any questions you might have afterwards, we'll be happy to address those. So we're going to hand it over to Dr. Kadehjian to start his slides. And like we said, if you have any questions, we'll address those at the end.
All right. Well, thank you, Blaine and Anna. And I especially want to thank American University and the Justice Programs Office for giving me another opportunity to serve you and your audience here today. I also want to thank Natalie, my co-presenter. You know, she's really the practitioner here. I'm a bit of an interloper. Well, not really, but she's the one who faces these issues like you, the audience, on a day-to-day basis. And I deal with them from a scientific standpoint. And so I want you to look forward to her presentation. So I start out with synthetic drugs, but there are a number of terms that are used: novel psychoactive substances, NPS. They're also called designer drugs because they have been designed, and also legal highs, and that's certainly an area that we deal with, whether they are in fact legal or not, and the drug designer people are trying to stay one step ahead of law enforcement. I'm going to speak about four groups: the synthetic cannabinoids, the synthetic cathinones, or the bath salts, some synthetic hallucinogens, and I would be remiss if I didn't talk about natural products as well. So this is why we're all here: our human brain, our vulnerability to altered states of consciousness. We like our drugs. Drugs make us feel good or they make us feel less bad, and we can't do anything about that. Our biochemistry is fixed. This is a great article, Our Pursuit of Intoxication, a 100-century romance with psychoactive substances. So we have long sought out these altered states and drugs that provide those. This last year I gave a presentation in Rome that dealt with synthetic drugs, and because of the historical aspect of the city, I decided I would bring us to this current point. So I'm going to show you a few of the slides that I showed in Rome. And this is from mythology to synthetics. So we had drugs and the gods and goddesses. We've long, in our mythology, had drugs named after gods and gods using drugs. And then we as humans discovered natural products. We learned about what plants had these effects. And ultimately, we were able to isolate those active constituents. We learned about their structures. We learned about the body chemicals that respond to those structures, like neurotransmitters and neurotransmitter receptors. And then by the 1800s, we had the golden era of synthetic organic chemistry, where humans figured out how to make molecules, their shapes. And that led to the development of the pharmaceuticals we use. But unfortunately, some of those drugs turned out to be modern drugs of abuse, and we call them designer drugs. And so the challenges that we face are this myriad of new drugs that we've created, and how can we identify them? And I'll address some of those challenges as we go ahead. This is a book called The Pursuit of Oblivion, Our History of Narcotics. And what's wonderful about this is this illustration on the cover done by Evelyn de Morgan in the 1870s. And it shows the mother, Nyx, which is night, the night, and her son, Hypnos, and that's where hypnotics comes from. The Roman word is somnos, where we get like insomnia. And notice what Hypnos is holding. He's holding poppies, and he's spreading poppies down onto the earth. So this is how night comes to us, is bringing the soporific qualities of poppies and morphine down to us. And I should note that Hypnos' son is Morpheus. And where does the word morphine come from? Morphine, the Greek god of dreams, Morpheus. So the poppies are a great illustration of how we get to designer drugs. And this is where we've isolated morphine from Papaver somniferum, the poppy plant. And chemists ultimately figured out how to convert morphine, the natural product, into heroin. So heroin is a great example of a designer drug. In fact, there's an interesting correlation between heroin and aspirin. I'm going to leave this for a second to see those of you who might know what the connection is. Well, it turns out that they're both synthetic derivatives of natural product. Heroin, diacetylmorphine, the acetylated morphine, and aspirin is acetyl salicylic acid. And salicylic acid was used, but it caused GI disturbance, and they learned that if they acetylated it, that it would then not have those properties. So they started to acetylate everything, and they acetylated morphine and made heroin. So these are two designer drugs. In fact, they were both marketed the same year at the turn of the last century, and both marketed by the same company. So it's a great example of our history of chemists figuring out how to make designer drugs. All right, now relax. Chemistry 101. Everyone who's ever heard one of my presentations knows that you have to see some molecules. Trust me, it's good for you. Okay, just squint your eyes a little bit. I'm sorry I don't have a pointer available to me, but in the upper left corner you see the structure of morphine, and below it you see the structure of codeine. And those are two natural products from the poppy plant. Well, all of these others, hydromorphone, hydrocodone, oxymorphone, oxycodone, dihydromorphine, dihydrocodeine, these are all synthetic derivatives from morphine. And you see how they kind of all look alike. The chemists have tweaked the molecule here and there, and you can understand how they all act as opiates on our body's receptors. And that's what chemists are doing. They're trying to tweak these molecules. And in the same way that those opiates bind to receptors, you can pick them all up with your drug test, because the drug tests are like receptors too, and the lock and key fit, and they recognize these molecular shapes. And this will be important when we think about how do we identify these new synthetic drugs. Okay, I'm going to show you a couple of more molecule slides. Just hang in there. So you see the structure of morphine and codeine, the natural products, and the synthetic ones, semi-synthetic ones. Well, there's heroin on the left, and it's got these two acetyl groups. And it looks just like morphine, but it's been changed a little bit. And then we have buprenorphine. And you can see they've stuck on lots of different groups on that molecule, but it still binds to opiate receptors in some way. And down below we have naltrexone, which is used to treat alcoholism, and you have naloxone. And again, the chemists have stuck these different molecules on there, still based on the morphine skeleton. So these are semi-synthetic drugs that have certain properties. Well, now we have other opiate active drugs like tramadol and Demerol, meperidine, fentanyl. We're starting to break the molecule apart. Fentanyl doesn't look anything like morphine, but it's 100 times more potent. So the chemists, the synthetic organic chemists, are tweaking molecules all the time to make new drugs. And sometimes they're trying to make them more potent. Sometimes they're trying to avoid side effects. I'm going to show you a few more molecules. Here you have crocodile, which is it looks like morphine, but they've changed against some of the structures. And then another molecule, W18, doesn't look anything like morphine, but it is 10,000 times more potent. So this is what chemists are doing when they're trying to make these designer drugs, is they're tweaking these molecules to trick our body's receptors more so than they were ever designed to withstand in terms of the natural products of our world. And here's methadone that is a substitute for morphine and heroin. Doesn't look anything like morphine. And similarly, propoxyphene, Darvon, also binds to opiate receptors. So chemists have this huge capability of making molecule after molecule. So this is a 1985 Doonesbury cartoon. And it shows them, you know, tweaking this. We just removed this molecule and voila, legal is sea salt. So this is about MDMA, actually, ecstasy. So this is a perfect example of the chemist trying to bypass the law. This, interestingly, is a patent from Merck, where they actually got a patent for making MDMA. And the date on this is 1912. So this is when the pharmaceutical companies are getting these organic chemists and teaching them how to make all sorts of different molecules that have different properties. So amphetamine, methamphetamine, MDMA, these were all made at the turn of the century. Well, now we have, in more modern times, a whole variety of psychoactive substances. These two books are PCAL and TCAL. PCAL stands for phenethylamines, that's like amphetamine, I have known and loved. And TCAL is tryptamines, that's like LSD, I have known and loved. And these books are hundreds of pages of how to make designer drugs and what effects they have. And you see that the authors are Alexander and Anne Shulgin, and I have to give a call out to Sasha Shulgin, Alexander Shulgin. He died 2014. And he's an organic chemist who lived in the hills above Berkeley, and he wrote these books and made all these drugs. And he's really famous for all of this. So I have to give a shout out in recognition of Sasha Shulgin and all the work that he's done. And we are haunted even today by some of his designer drugs. So where do we stand now? We have many publications about these designer drugs, and I'll have a list at the end of some of these resources. So we're learning about the huge number of these drugs. This is from the Journal of Psychoactive Drugs, and you can see the third column from the left, the number of substances identified, 650. There's cannabinoids, cathinones, tryptamines, psychedelic drugs, herbal plants, huge numbers of drugs. And look at the number of brand names on the far right. I was just at the Society of Forensic Toxicology meeting in Dallas, and 27% of all of the presentations were about these designer drugs. There were 43 various presentations, either poster or oral presentations. So our toxicology community is dealing with this myriad of new drugs. We have this pilot program, the Community Drug Early Warning System, and then that expanded to NDUS, which is the National Drug Early Warning System. And these sites have tremendous information available on all these different drugs, like the fentanyls, which are very powerful opiates. We also have the Drug Enforcement Administration, who publishes a lot of information. So you see synthetic cannabinoids, the tryptamines that are like opioid analgesics, for example, the cathinones, the bath salts. So there's a lot of really useful information. We're also getting information from Europe. There is the European Monitoring Center for Drugs and Drug Addiction, EMCDDA, and they put out these drug reports, and they survey many European countries. So many of the designer drugs that we see here actually have come from information from Europe and the Far East. So what's the legal history here? You remember the Doonesbury cartoon, if we tweak this molecule, we can make it legal. So I've got just a few slides on how we are dealing with this. So 1906, we had the Food and Drugs Act when these patent medicines were poisoning everybody, and they said we need to regulate this. And then we had drug control treaties that we deal with internationally. And our first law was in 1914, the Harrison Narcotic Act, where we tried to regulate opium and cocaine. And then by 1970, we have probably one of the most significant, the Comprehensive Drug Abuse Prevention Act, and this is where the 5 schedules, Schedule 1, 2, 3, 4, 5, and Schedule 1 drugs are the drugs that have no approved medical use and have addictive potential. So marijuana under federal law is Schedule 1 drug, for example, and that's part of the Controlled Substance Act. The Drug Enforcement Administration established shortly thereafter 1986, the Anti-Drug Abuse Act, and then importantly for these designer drugs, we have the Federal Analog Act. And that's saying, well, do we have to pass a new law every time the chemist tweaks a molecule here or there? These are called analogs, kind of looks like it, like we change a chlorine for a bromine or a fluorine atom. So they said if a drug is substantially similar in its molecular structure and its effects, then it can be regulated. even though we don't have a regulation specifically for that individual drug at the time. And it has to be intended for human consumption. Well, you know, all these bath salts and spice that you get at 7-Eleven, they all say not intended for human consumption, winky, winky. And there's a real legal issue surrounding what is substantially similar. So they get these chemists to go into court and argue whether a molecule is substantially similar or not. So the cannabinoids got the first regulatory attention by the Drug Enforcement Administration of these designer drugs in 2011, and the DEA can temporarily schedule it until they have a chance for full review. And then we have the bath salts that were then regulated shortly thereafter. And then in 2012, we had a major act to deal with this issue, Synthetic Drug Abuse Prevention Act. And it lumped together a lot of these drugs, the bath salts, the synthetic stimulants, the cannabinoids, hallucinogens. And the most recent action is on metraginin and 7-hydroxymetraginin, and that's known as kratom. And that acts on opiate receptors, and the DEA had intended to schedule it, and that's what they published in August. But there was a furor about it, so they've since withdrawn that notice of intent, and it will now come under review, and there'll be a comment period that lasts, I think, until December. So that's sort of an update on where we stand. But it's this analog act that covers a lot of these drugs. So let's go class by class. Let's first talk about the synthetic cannabinoids. I like that word because it mimics the action of cannabis. These molecules don't look anything like cannabis or the structure of THC, but they mimic the properties of cannabis, and so we call them cannabinoids or maybe cannabinoids. So, all right, here's our marijuana, and then we have a long history of the natural product going back thousands of years. Excuse me. 1964, we learned about the active constituent in marijuana, that's THC. 1988, the receptors are starting to be cloned. 1992, we find our body has its own internal marijuana called anandamide, another receptor clone. And now, with all of that science base, we now have these synthetic drugs, now that we've learned about these molecules and their receptors. So here we have synthetic marijuana sold as incense. This is a New York Times article. And, you know, do her parents know that she was in the New York Times smoking what's called spice? So this is where the synthetic cannabinoids come from. Okay, at the bottom is THC. And you see it's a very fatty molecule. That is, it's only got 2 oxygens on it, no nitrogens. It's just all carbon and hydrogen. This is like fat, wax, oil. Well, look at spice up there on the upper left. It's also very fatty, but it doesn't look anything like THC. And there's another win up there on the upper right. It doesn't look anything like THC. So even though these drugs bind to your cannabinoid receptors in the body, they look so different that your typical marijuana drug test isn't going to pick them up. They look too different, and they're generally tens to hundreds of times more potent. So you understand the nomenclature. I'm going to make you cognizant here. The JWH, that stands for John W. Huffman. And here he is, John W. Huffman. He's a synthetic organic chemist, and he was at Clemson University, and he synthesized a whole family of these molecules, these JWH molecules. Well, the other people have been making these molecules. So if you see HU210, that's Hebrew University, JWH, John Huffman, Win, Sterling Winthrop, a pharmaceutical company, SR, Sanofi Research, AM, Alexandros Bakrianis, CP, Pfizer, AB Abbott. So pharmaceutical companies are very interested in these cannabinoid receptors, CB1, CB2 receptors, for a number of reasons, and therefore they're making these molecules. Well, the designer drug people say, well, we can make some of them too, and maybe we have a different goal than the others, and we're going to make different molecules. So this shows the number of publications now for these synthetic cannabinoids. And you see down in the middle when the receptors were identified and the natural neurotransmitter was identified, and then suddenly there's this explosion in these synthetic drugs and synthetic cannabinoids. The United Nations Office on Drugs and Crime has brought this issue up and has documents about it. The European Monitoring Center has information. You can download all of these, learn everything you want about these drugs. And just to illustrate the complexity here, the middle of the circle shows the basic structure of these synthetic cannabinoid mimetics. They have a core structure, but around the left part of the circle, you see all the different cores they have. And then the tail is in this greenish color, and you can see all the different tails that have been made. And then the ring, all the different rings that have been made. And you can imagine the huge number of combinations that exist. So the designer drug people just move around the circle and make one new drug after the next, and the regulatory people have a terrible time keeping up. And the same with the drug testing people keeping up. How do we identify these drugs? A huge challenge. Well, because they've been around for a while, we're starting to learn more and more about the pharmacology of these drugs, how they act on receptors, the adverse effects, the toxicology. So we do have information available about these drugs. We understand the effect of these drugs in driving. They're showing up in drugged driving cases. We also have the Drug Abuse Warning Network, DAWN, and they survey emergency rooms around the country. And so we're learning about the adverse effects of these drugs and how they're showing up in emergency rooms. But a great challenge is that they often don't know what the person took. And unless a friend comes in and says, yeah, he bought this at 7-Eleven, we don't know what it is. And generally the hospital laboratories, they don't know how to test for these things. So it's very difficult to get real information about these. We are learning about adverse effects. I showed you the impaired driving. This is psychosis. We know that psychosis is associated with marijuana use to some degree, and they've certainly seen that with these very powerful cannabinoid mimetics. Again, these are many times more, tens to hundreds of times more powerful than marijuana. So we are learning about how the body handles them and detection methods. We can't really do controlled dosing studies. I can't invite some people in and say, here, you want to take this? We don't know what it is and we don't know what's going to happen to you, but we want to find out what comes out in your urine or in your hair or in your sweat. So very difficult to get accurate information, but we are starting to get information about these drugs. We're learning about how long they can be detected, and because they're fatty like marijuana, they can stay in the body. And we're developing simple tests, immunoassays, the analyzer-based tests. But because there are so many molecules, this shows no cross-reactivity. The table 3 up on the left, it says drugs showing no cross-reactivity. And those are all cannabinoid mimetics that don't react with the antibodies that they make in these kits. But the kits are improving now, so we're now getting kits that have cross-reactivity to a wide variety of these drugs. I don't expect you to pay too much attention to this other than to understand the developments that we're making in drug testing and being able to identify many of these. But again, remember, these change on a day-to-day basis. So that's the situation for cannabinoid mimetics. I know Natalie is going to talk about them a little bit more. I'm going to jump now to the bath salts, or the cathinones. And this all started with Ma Huang, which is ephedra sinica. And that's where ephedrine comes from the Chinese plant, and it's called Ma Huang. And this has, again, been known for thousands of years. But the next development was khat, this Catha edulis, which grows in Ethiopia and Yemen. And understanding those structures led to the synthesis of amphetamine, methamphetamine, ecstasy, and now our designer cathinones. So these are khat leaves, and they're wrapped in banana leaves and shipped, and people then chew the khat leaves and get this molecule called cathinone. And khat comes from the Horn of Africa, Yemen, Ethiopia, Somalia, that area, that part of the world. And then it's shipped around. So again, more molecules. You see our natural neurotransmitters at the top left, dopamine and noradrenaline. Ephedrine, Sudafed, these are natural products. Well, at the upper right corner, you see cathinone, and that is the active constituent of khat. And it's just got this extra keto group, this extra oxygen on there. So it kind of looks just like amphetamine and methamphetamine, which is in the middle there. And now we have all these cathinone derivatives, and you can understand why they are stimulants, because they have molecular structures that look like amphetamine and methamphetamine and our natural neurotransmitters. And on the right, you see more of these cathinone derivatives where the chemists are starting to add molecules and tweaking them around. And again, the chemists are putting all sorts of different groups on these various bath salts. And you can see how they're mimicking ecstasy in the bottom, two molecules. You have ecstasy on the left and MDPV on the right, and they've tried to mimic ecstasy a little bit. And here you have a little article about a Chinese professor who is making these drugs and shipping them over to the U.S. He started a company. So a lot of these synthetic drugs are actually coming from other parts of the world. Okay, I'm going to move on in the interest of time. But we're learning about these drugs, and we're learning about drug testing. So this is a paper, a recent paper on testing for designer stimulants. And they looked at 16 of these synthetic cathinones, and can you pick them up with conventional tests? What shows up in urine when somebody uses one of these drugs? And it turns out some of them can be picked up with ureamphetamine assays and some can't. And the challenge is you get a positive result with your amphetamines kit and you send it to the lab, but unless they're testing for all of these different cathinones, they may report that as a negative. So it's a frustration in the drug testing world. Okay, on to synthetic hallucinogens. So these are drugs like LSD, and again, a long history of natural products like psilocybin was called the flesh of the gods back in 6000 BC. We had the North American, Mesoamerican tribes doing peyote and mescaline. We learned about ergot alkaloids in the Salem witch trials, and then that ultimately led to the development of LSD. Salvinorin A, again, Mesoamerican, and it's the most potent natural hallucinogen known. And ayahuasca, where they take two plant materials from the Amazonian jungle and get their hallucinogenic effect. So these are all the natural product side of things except for the LSD. And now we have back to Sasha Shulga in his books where he's teaching you how to make a lot of these molecules that are hallucinogens. And here's one of the N-bomb series. You may have heard of this, the N-bomb and the NBOME. And I want you to understand where the nomenclature comes from. So you can go back and look at this molecule later. But the NBOME25I, it all from the chemists want to name these things. So now you can understand where the naming comes from. I won't spend any more time with it. But these are very powerful designer drugs, and we really don't have good tests for them that are easy. They really would have to be tested for in a laboratory. And finally, I'm going to go to natural products, and I'm going to talk about ayahuasca. On the right, you have two molecules that are in one plant, and on the left, you have two molecules that are in another plant. And when you take this plant, these two plants together, the molecule on the right inhibits the enzyme that would break down the molecules on the left, and you wouldn't have any effect. But when you take them together, the molecules on the right allow the molecules on the left to go through the body and have their hallucinogenic effect. And this is amazing that these natives figured out how to do this when you took these two together. And you can go into the Amazonian rainforest and have your ayahuasca experience. So here we have another natural hallucinogen that you may have heard of, and this is salvia, Salvia divinorum. That's not my back porch, by the way. I want you to understand that. And this got a lot of attention by some claims that Miley Cyrus was in fact smoking salvia, but they said no, that was not salvia she was smoking, but that's how it got written up. So this is salvinorin A. It is the most potent natural hallucinogen known, and we don't really have easy drug tests for this molecule. But again, chemists understand the structures, and they can now play with these. And now we have kratom. This is, again, a natural product that you've heard about, Metragine speciosa. It's in the same family as coffee and one of the ayahuasca molecules, interestingly. And these are many times more potent than morphine, bind to the opiate receptors. And recently, as I showed in the regulatory area, they're trying to put a damper on availability of these molecules. But people say, but wait a minute, we like kratom. Kratom acts on opiate receptors like methadone does. And there's a discussion that addicts can actually use kratom and avoid relapse by using this. So the DEA got all these letters and decided, okay, we'll hold off. Let's get some research from the FDA. So to sum up, we have this Pandora's box that's suddenly been opened by all these chemists. We've been lucky that it hasn't lasted longer. So that it didn't start sooner is, I'm sorry, what I meant. So we have these designer drugs, and the challenge is to know what are these molecules and how do they act in the body and what shows up in urine or hair or oral fluid or sweat if we want to detect these things. So we have to understand their pharmacokinetics, how the body handles them, and ultimately their effects. So we have to know how they go through the body, how they're metabolized, how they're eliminated. And it's very difficult to do these studies because these are unknown and dangerous drugs. So it's truly a challenge now. And the drug that we take that binds to our brain receptors may not be the same thing that comes out of our body, because our body, our liver, and our kidneys filter the drugs, our liver breaks them down. So we need to know what shows up in each specimen. And I've got urine down on the bottom right there, this antibody in yellow because of urine. And we have to remember that these drugs can all be affected by urine dilution. So if you're doing urine drug testing, the dilution will affect these drugs, the concentration, just as they will affect any other drugs. So if you're doing urine testing, you've got to take this into account. So they are now studying these immunoassays and how they bind to all of these different designer drugs. What can your test pick up? What can't they pick up? And laboratories are constantly trying to develop these techniques. So what are our challenges here? Hundreds of compounds, uncertain legal and regulatory status. How do we detect them? What are our methods? Immunoassays take a long time to develop. Those cup-type tests or analyzer tests. Mass spectrometry, that they can identify these, but it's expensive, and you can't develop the test unless you know what standards you're looking for. Are you looking for the parent drug and the metabolites? And then how are they broken down? Do they stay in the body a long time, a little time? What are their effects? We can't really do controlled dosing studies with many of these drugs because they're so dangerous. And then there's this issue of how do we treat people who are using these drugs? What treatments will work? So this is my last slide. So here's a list of some resources. The National Institute on Drug Abuse, the drugabuse.gov, has tremendous amount of current information. The DEA has several documents available to you on what they're finding in drug busts and what drugs are showing up. I showed you the National Drug Early Warning System that you can see. That's out of the University of Maryland. The European Monitoring Center, look, they have identified over 560 substances in their European warning system, and just in 2015 there were 98 new ones. So it's just hard to keep up with all of this, but at least these are all places where you can get accurate information about their status, what's showing up, and their effects. Another website I like is called Erowid, and this is a balance between actual users and PhD scientists. So you get a little bit of the science and a little bit of the street lore. It's a great website to explore those two issues together. We have maps where there are studies going on psychedelic substances who believe that these are useful. And then another one, lyceum.org, which is about entheogens, these drugs that make you have feel-good experiences. So I went through a lot of material very quickly. Hopefully I've given you a sense of the scope of these drugs, the challenges we face, and the limitations. Now, we will turn it over to Natalie, who has to deal with this on a day-to-day basis, and she can now give you the practical issues of how she deals with it.
All right, thank you, Dr. Kadehjian. Also want to thank the Justice Programs Office for giving me this opportunity, and Blaine and Anna, they've both been great partners on this as well. So I think that was a great background and tie-in to what I'm going to talk about here. I'm really looking at this more from the adult drug court practitioner's perspective, and what we're seeing in drug courts, some strategies on how to address it, funding issues that come up here. So moving into my slides here, the first patterns I want to talk about are four main substances that we're seeing reoccurring in adult drug courts. So as Dr. Kadehjian mentioned, the synthetic cathinone use, also known as bath salts or flocka, heard flocka a lot in the South, but mostly bath salts is commonly known by. Our big issue we're seeing in drug courts, synthetic cannabinoid use, as Dr. Kadehjian also mentioned, spice, K2, incense, and then kratom. That's actually a big one I'm going to spend a good amount of time on. That's a big one here that's really causing a lot of problems in drug courts. He mentioned the fentanyls, also known as China white. Are there other substances that are out there? Yes, of course. Listening to Dr. Kadehjian, there's a wealth of synthetic drugs, natural products out there that are being used by drug court participants. But I just kind of want to focus on these ones. But of course, policy and practices, all of that will apply to the broader scope of the synthetic substances out there. So what does this look like in a drug court participant? I think that's important to understand, especially when we get to the part of incorporating this drug testing into the program. So synthetic cathinone use, so it mimics, as Dr. Kadehjian mentioned, similar to amphetamine use. So you'll see a lot of folks with anxiety, the euphoria, the confusion, weight loss. Red flags for me are when you have a methamphetamine user that's testing clean, but just something's not right. They're missing appointments. You might see some weight loss, some of that hyperactivity. That might be some red flags to look at. In terms of availability, this is actually getting a little harder to find for participants. I think there's some liability issues with the head shops, and which is where they used to get it a lot because of the high rate for addiction and abuse for bath salts. So it's getting harder to find, but it is also sold on the streets. So this is kind of a new area for drugs being sold on the street, are synthetic drugs. So that's one thing to keep in mind. Synthetic cannabinoids, as Dr. Kadehjian mentioned, they're more potent most times than marijuana use. And it's actually the compound itself that's sprayed onto dry leaves, which are then smoked. So it's not the actual leaves that are the causing the effects. It's the actual compounds they're spraying on the leaves. It's available in liquid form for vaping. It's available at head shops. And this one's relatively easy to find. So kratom, this is, as I mentioned, the big one for us right now. I actually took this picture. I went into a local head shop, which I like to do, and I encourage practitioners to do as well, to see what's going on out there, what's being sold over the counter to participants, and just how it's marketed and everything. So I took this picture. This is just an example of how much shelf space they're dedicating to just kratom. And this was only one section, all the different types that you can purchase. I mean, there's different names there, as you can see. So it's just sort of interesting to see how much space they're dedicating to this. So kratom is similar. Folks report that it's similar to an opiate use. As Dr. Kadehjian mentioned, it binds with the opiate receptors. Clients report like a mixed stimulant and sedation effects. I see a lot of folks that are using kratom get really sweaty. I've seen weight loss. And then also, as mentioned before, there's discussion around using this for recreational, at this point, pain management, opiate addiction, which has put a halt on the proposal to move it to a Schedule I. And also, as I mentioned, it's very, very available at head shops. It's very popular. When the ban was going on, there was huge clearance sales, so it was pretty reasonably priced. I think this is something that folks really need to be aware of, that drug participants very easily get their hands on. So fentanyl, this was mentioned before as well. It's similar to opiate use, as Dr. Kadehjian also mentioned. According to drugabuse.gov, it's 50 to 100 times more potent than morphine. So you can imagine the effect on someone who's using this with the slurred speech, the heavy sedation. We've had folks that were on it that, were drooling and very unresponsive. So it's very concerning. I mean, these are dangerous. Most of this is purchased online or on the street. I haven't seen it in any local head shops, at least. So it's just something that's regularly dealt on the streets as well. So in terms of synthetic drugs and the impact, and specifically on drug courts, I mean, I think there's a lot of research that still needs to be done, but one thing we do know is that participants are using it. There was a study done here that I've referenced that in a residential treatment facility, 71% of the patients reported using synthetic cannabinoids to get high without having a positive drug test. So that's a very significant number of people in a residential facility. And of course, you know, some of these barriers are that they're specifically designed to avoid detection. The testing's expensive. There's not a standardized cutoff limits, et cetera. So this is a little bit of a challenge we face. If you want more information on designer drugs, the effects, the history, et cetera, this is a really good practitioner sheet to read by the NDCI. They specifically get into a lot more detail, but I want to kind of more dive into some of the policies, procedures, and things. So what does this mean for us as practitioners in terms of policy and just an awareness? I think it's important for us to have these discussions with our teams and things. So I want to look into the adult, here we go, the Adult Drug Court Best Practice Standards Volume 2. So this is a very frequent guide for practitioners, and it does mention in here synthetic drug use. So looking at Section D under drug testing, they mention it's important to have a wide range here on the last part of the section. It says drug courts should select test specimens randomly and frequently and examine them for a wide range of potential drug abuse that might be emerging in their population. So, and above that, they had mentioned synthetic drug use. So it's very important that we're doing a random and frequent wide range of drug testing in our programs. So some suggested policy for synthetic drugs in drug court programs. I think it's very important to have a clear understanding in any participant manuals, any drug testing contracts, any intake paperwork processes, et cetera, orientations, that this synthetic drugs and natural products, they're not allowed. So it's one way to do that is to ban the use of substances sold as not for human consumption. Because as Dr. Kadehjian mentioned, that's one way it's typically, they go around the laws around that, and they're typically marketed not for human consumption. I think it's important to also let participants know that they will have regular and random expanded drug testing if that's true, which hopefully this will help you programs get to that point. But I think it's very important to let them know. This isn't something that they haven't thought of or they haven't heard of. Synthetic drugs, you won't be introducing them to them. Most of our folks have heard about them at the very least. Another important factor is to have policy discussions on how to address positive synthetic drug use. There will be opinions, you know, it varies from the defense to, you know, the district attorney's office. So I think it's important to have these discussions before it happens. So how are folks going to address positive synthetic drug use? So let's get into that a little bit. We have, this is also pulled from the Adult Drug Court Best Practice Standard Volume 2. So basically what they're saying here is that there are two possible behaviors to address if someone does admit or have positive UA for synthetic drugs. You have the new use, of course, and then also this added layer of effort at deception, which occurs a lot more frequently with synthetic drug users just because of the nature of how they're designed. So to break that down a little bit, so you have the new use. I would recommend following just the proximal distal goal model. Most folks are familiar with that. Proximal goal is the goal that you have the skill set to accomplish and sustain. So for someone with significant clean time, you know, a proximal goal would be to maintain that clean time. Distal goal is something they're working towards. So sanctioning model around that. In the efforts of deception, this one's pretty easy to just tease out. Did they admit to using synthetic drugs before the UA or before being confronted with the UA? If the answer is yes, then I would say there probably wasn't an attempt to defraud the test. If they say no, then it's possible that then there's another sanction here for the effort at deception. So what to do next? So you have the positive test, you've addressed it, then what would I recommend next? I would definitely make sure that the treatment team is well aware of what's going on with this participant. They might need to do some reassessments, look at their needs, look at the case plan around what's going on. It's very important to make sure treatment's in the loop on this, especially with if you're catching it through additional testing, make sure they're getting those results. Just the communication can be really important here. Also, if you get somebody that has admitted to or has a positive UA for synthetic drugs, it's very, very, very important to make sure you're continuing to test them or continuing to have expanded drug testing with them. It's both for accountability, for program fidelity, also to make sure they're getting their needs met. If they're using substances we're not detecting, then we're likely not applying the right treatment to them, so we want to make sure we're well aware of what's going on with these participants. Also, we've seen a lot that these synthetic drugs and these substances can expand within groups of the participants. So, for example, we had sort of a bath salts epidemic for a short period where we had a large group of participants that were friends, and one person tested positive for bath salts, and it kind of led to a string of multiple folks that we found out were using them. So it's very important to make sure you're really looking at your population, and that might be a good idea and a good strategy for especially risk-based testing, which we'll get into, for monitoring for these synthetic drugs. So how to incorporate these expanded testing for, I mean, as Dr. Kadehjian mentioned, there's a lot of challenges around this, but this is some good advice that I can pass along as sort of a starting point. I know the toxicology side of things is still always ongoing and developing, but just in terms of policy, here's what we have. So first off, I encourage you to find out what your local Medicaid plans cover. We actually locally are able to bill our local Medicaid plan for some expanded testing, so that's pretty helpful. If you're using your community justice agency for drug testing, I'd consider, if you can't move all of your drug testing over there, just consider maybe doing some random expanded testing through your treatment agency so they can bill. That's one strategy we've implemented in our program just to help with some of the costs associated with the expanded testing. Also, if you're considering bringing in some outside or additional support around testing, shop around. There are lots of labs out there, lots of different prices, products, etc. That can meet your needs. There's places that will do custom panels and lab testing, instant testing, etc. So I just encourage you to shop around. Another suggestion is to consider incorporating into this request, into your grant request. Funding in your grant request is an argument that you could easily make. As I mentioned, it's in the drug court, NADCP drug court standards. There's lots of research out there, you know, that this is an issue. So I think it would be a good point to make in the grant request. Also, consider creating a budget that you have right now. For any finances you have right now, consider creating a budget specifically for expanded testing. So are you able to reallocate any resources? Are you able to request additional resources from any funders, being armed with some of these arguments in the adult drug court standards? And I think it's important to discuss synthetic drug use within the team so there's an awareness of it. Also, this will go back to all of the funders as well, that this is an important issue. So I think that's an important part, is to make sure your programs are having these discussions. As I mentioned, risk-based testing. This is a good strategy for those that have limited funding, most do. So if you're looking to do and target specific participants for different testing, I think there's some relations here that can help determine what to test for, who to test for what. So the marijuana users, obviously, you're probably going to want to watch a little bit more for the spice and K2. Synthetic cathinones would be more like your methamphetamine, amphetamine, and cocaine users. And the kratom would be more, I've seen mostly opiate users turn to kratom, but there's some stimulant users as well, or the polysubstance users. Fentanyl is definitely comparable to opiates, so that's one I would watch for your opiate users. There's also some additional research out there if you want to look on some of the demographics, so feel free to do that. This is just a good general guideline I go by. So just some tips on drug testing in general that will help with synthetic drug testing issues that we're seeing. I encourage folks to not disclose when you're doing drug testing and you're sending samples to the lab, to not disclose to the participants necessarily what it's going to be tested for. And I do that, I would suggest that coming from a place of trying to not catch them doing something wrong, but just make sure that you're encouraging honesty and discouraging any efforts at deception. So just create this understanding in your participant manual. I think it's also cost effective as well. If the clients if they know exactly what they're going to get tested for, then they know exactly what they can use and not get caught using. So I think it's important to sort of just leave it more open and just have that understanding. I'd recommend creating a disputed drug test agreement. This is especially because synthetic drug testing is so expensive. So what that looks like is if a participant provides, say, an instant test, if you're using instant on-site testing, and they're disputing it and it's showing positive for spice, and you are going to have to send it to the lab to get a confirmation result, which is very expensive, I think it's important to have some sort of agreement where they stop and think about the situation and they're playing the tape all the way through, I guess you could say in treatment terms, of what the potential consequences could come from having to go through that full process if it is in fact a true positive UA. So I think it's important to point out there might be further sanctioning for continued dishonesty, and possibly they're subject to lab fees if they're found to be dishonest and in violation. I just think this is a nice way to get them to really stop and think. A lot of the participants are nervous, especially if they're being caught for something such as synthetic substances. I think it's important to just have that moment for them to just stop and think, and there's a good teaching moment there as well. And as I mentioned before, just talk about synthetic drug use. You're not introducing them to something they haven't already heard about, haven't already maybe seen or tried. So I think it's important to just show from a competency level perspective that we're aware of this problem and we're aware that this is going on. I mean, especially if you're testing for it, I think it's a good conversation to have with participants and just be open with them so they know we're not, you know, sort of out of the loop of what's going on. So yeah, thank you. I am open to taking any questions. I think we're going to have a little short period here for questions. Also, my email address is there if anybody has any additional questions as well that they don't necessarily want to ask here on an open session.
All right. Well, thank you, Natalie and Dr. Kadehjian, for those great slides and wonderful comments regarding synthetic drugs and designer drugs and drug courts. I did have a quick question while we wait. People in the audience, if you want to ask any questions, you can type them in the bottom in the Q&A box. So please feel free to do that. But I wanted to ask Natalie, I know that prices probably vary a little bit on the expanded testing, but in your experience, what has sort of the price range been like, and is it something that drug courts can afford to do at least on a semi-routine basis?
Yeah, I mean, I've seen it varies obviously if it's an instant test or if it's a lab confirmation. For example, kratom I've seen cost anywhere around $60 to $80, unfortunately, per test. But again, that's something that we can bill for, at least locally with our Medicaid plan, bill insurance for. So that's a big strategy that we've been utilizing, is to bring in the insurance companies. Some of the other instant tests are less expensive, but again, if you have a dispute issue and your program requires confirmation testing, then you'll have to spend that money if they do go on and dispute. So that's another suggestion of why I have that dispute form. So it's just really shopping around and trying to utilize Medicaid and other resources out there.
Okay, fantastic. And then I also had a quick question for Dr. Kadehjian. You delved a lot into the science of synthetic and designer drugs, and I was curious, I guess, as to what you see the future of these drugs looking like. I know that the designers of these drugs aren't necessarily trying to make them more potent or dangerous, but I was curious if you see that as something that could happen as a consequence of continued sort of tinkering with these molecules.
As I indicated, the designer drug people, for the most part, are not pharmacologists trying to, get the best drug that they can. I think the motivation for all these changes has really been one of legal and regulatory status. Obviously, they want the drug to have some desired effects, otherwise there'll be no market for it. But what we've seen is this ability of these synthetic chemists to really make molecules that are incredibly potent with all this knowledge of the receptor. Exactly, they have computer-assisted design of receptor sites to design molecules. So I think, the future is what we're seeing currently, that these new drugs have a wide spectrum of effects and potencies and adverse effects. So I just see this continuing. Granted, the Analog Act allows for grouping these drugs together, and I know there's been some case law addressing what is an analog. If you just change this one little thing, is that an analog or not? But you also have to demonstrate that it has comparable effects, and that's not always easy to show as well. So I think, from the turn of the century, when we had the organic chemists trying to synthesize these drugs, the pharmaceutical companies, we've lived like a Goldilocks era where we only had a handful of drugs to worry about. We called them the 9 to 5. We only worried about marijuana and cocaine and opiates and such. And now suddenly we have this explosion, and we've just been lucky in effect that didn't occur decades and decades ago. But I think, as that article showed, the Pandora's box has been opened. So I just think we face greater and greater challenges. And from the drug testing standpoint, I think it's going to offer continued challenges. There probably will not be simple, easy tests that are going to pick up all of these new designer drugs as they change on a weekly basis even. And so testing may be forced to go to more sophisticated laboratories where, as Natalie indicated, the cost per test can be $60, $80 or such. And that was certainly something that was brought up at the most recent toxicology meeting, that the toxicology labs are the ones who are really trying to stay on top of all of these new drugs. Anyways, that's my sort of not good to hear news, let's say, about the designer drug situation. I think Natalie's information about what to look for, create more targeted responses, knowing what the properties of these drugs are and knowing what to look for, and then having the ability to have some way of identifying them. One final thing I want to note, you have the slide contact information up, and I just want to point out that my last name is not spelled correctly there, but that's okay. It took me a long time to learn how to spell my name, so it's okay.
Apologies for that.
Yeah.
I just have one more question then that came in for different questions for each of you, but Dr. Kadehjian, I was wondering if you could just briefly, we didn't really touch on it, but I think there's a lot of people don't have a sense of how dangerous some of these synthetic and designer drugs are. And I was just wondering if you could talk about a little bit about what you've seen in the work that you do as far as some of the public health impacts.
Sure. Well, as I said, it's certainly shown up in impaired driving issues. And there are YouTube videos of people who are having schizophreniform psychoses as a result of use of these very potent drugs. I mean, if we even think about the medical marijuana situation, where people have very high THC concentrations in their cookies, for example, or in their gummy bears, and they unfortunately don't know how much they can ingest, and the oral ingestion doesn't allow you to titrate your dose. And for many of these new drugs, I mean, I thought the kratom slide that Natalie showed was spectacular. I mean, who knows what the actual metriogenin, 7-hydroxymetriogenin concentration is in every one of those. So what you thought was okay to take at one point is not. And the same is true in the opioid epidemic, where if you have, you know, Vicodin or OxyContin, you know what those pills contain and how much you're taking. When you switch over to heroin on the street or designer fentanyls, you have no idea how those correlate. So I put up a slide of DAWN, the Drug Abuse Warning Network. So we're seeing a lot of these adverse effects. Marijuana, these synthetic cannabinoids, there are really no deaths associated with marijuana use. I mean, toxicology deaths associated with marijuana use in the literature. But there are deaths associated with synthetic cannabinoids where people are jumping off of buildings, et cetera. So I would say the toxicology literature is rife with examples of how dangerous these drugs are.
Okay. Thank you for that. And then, Natalie, I just had one other question for you, if you would be so kind.
Yeah.
And I guess I was curious what you think, kind of like, you laid out a lot of great strategies, and I wanted to know if there was one in particular that you think is sort of the most important strategy for drug courts to implement in the short term to start addressing synthetic and designer drug use, like, right away.
The most important, I would say, is to contact your local Medicaid providers and see what can be covered. I mean, that potentially is a very, very low cost or no cost solution to doing some of the expanded testing, at least for some of the most common synthetic substances. So that would be the most important strategy. I mean, we did that, and we were immediately able to increase the amount of expanded testing we were doing just based on that. It didn't cost us as much, you know, $30, $80 a test. It adds up pretty quickly. So that, I think, would be the most realistic and feasible, quick solution to just see what's covered. I think that would be a good place to start.
Okay, great. Thank you for that.
I'd like to chime in on that, Blaine, if I have a moment as well.
Yeah, absolutely.
Yeah, one of the issues that we deal with, and Natalie brought up the issue of deception, I can never testify about the intent of a donor from the toxicology information. I never know what the intent of the donor is, but I do know that people can attempt to distort the drug test results that distorts the trier's ability to truly understand the drug use status of the donor. And since we've been talking about urinalyses, I want to re-emphasize the important role that dilution plays. Anyone who knows anything about drug testing in urine knows that they can consume lots of fluid prior to their test, and that can be as short as 15 minutes to as long as 2 hours. And by this supranormal fluid consumption, you dilute the concentrations in your urine by a factor of 10 to even 20-fold. And this has long been known as an issue, and that's why in the workplace testing, every urine is now tested for creatinine and or specific gravity. I prefer creatinine measurement. But this is absolutely going to be true for all of the designer drugs as well. Any of the synthetic cannabinoids, the cathinones, the hallucinogens, these are all going to be affected by urine dilution. So an important strategy for all of your drug testing is to make sure you monitor dilution and have that in your policy and procedures where they're notified up front that dilution is not acceptable, absent a note from a qualified renal pharmacologist or, renal expert. So again, that's another very practical thing to remember to consider with these designer drugs as well.
All right, thank you for that, Dr. Kadehjian. I think that's great advice, along with Natalie's advice on sort of ranking policies and strategies. I think we are done with questions. I don't see any more coming in. So I don't know if either one of you have some closing comments you want to make before we end this webinar, but you're free to do so if you'd like.
Yeah, I would just like to say I think it's important just for all the practitioners to really, in the local areas, to really get together and look at patterns that they're seeing within their own areas. So if there's any kind of listserv going around with maybe with the coordinators across the state or the DAs across the state, just to talk about the patterns they're seeing in their area, because I'm sure these patterns change within different regional areas. So I think it's just important to communicate just with each other and then just look at patterns and ask for more strategies. That's how I've learned a lot of different strategies, just by talking to my fellow colleagues and practitioners. So I think that's really important, and feel free to contact me if there are any more questions as well.
And I'll add to that that there are numerous sources in your communities that help you target your programs. So, for example, find out what the police are encountering. Find out what's showing up in your local emergency rooms. These are also resources that can let you know what's going on in your community, so you can tailor your testing program appropriately. So those resources are also useful to consider.
All right, well, I want to thank Dr. Leo Kadehjian and Natalie Reyes for presenting with us today. And I want to also thank everybody who joined us on the webinar. If you have any other follow-up questions, please feel free to contact Justice Programs Office or the contact information for Dr. Kadehjian and Natalie.
Thank you.